Alright, this is the next video. Something quirky that I forgot to mention in the terrain model is in the terrain object manager. I have two maps. One's the one that you would expect that holds the made terrain when it uh, gets in a height map file and like the side length, max height, and zero height. And the other one I have is num cell rows on model map. The whole reason for this part is because I want the ability to load up a terrain model and an object separately. I forgot. I don't know why I wanted that. I think it just adds like a level of um, organization. Either way, I want to be able to do this part separately. However, when you make the model, that's when it actually goes through the TGA, and you can find out how many cells there are per row. Like if it's like 32 by 32 or 256 by 256, that's when it finds out. But since these are two separate calls, I needed a way to retain that value such that the made terrain, load terrain object, this terrain that got created can actually hold on and figure and know how many rows there are. And that's the only reason for that map over there, for this map, just so I can retain that value. And when I actually get to the part where it creates the made terrain, it uses the model key um, to put in as an argument the number of rows there are. So that's pretty much terrain object manager. It's got a map. It's got two maps, one that just holds data so that the other map can be created properly. It's got well, yeah, well that's it. And at the end, it unloads all and it properly deletes everything that is necessary so that there aren't so everything is properly cleaned up. So going straight from there to the actual terrains. As I said, that's the terrain object manager, and you can get yeah that's the terrain object manager. But there's the terrain manager, and that's the thing that actually controls the terrain. But it's really simple. All it has is set current terrain or set no terrain, and it's really just defaulted to no terrain. And if you set the current terrain, it's gonna call terrain object manager the asset terrain manager. Um, use the key and then set the current terrain to that. And terrain manager has a draw call that gets called in the scene because terrains are per scene. The draw call terrain man draw current terrain. That's it. There's nothing fancy going on. There's nothing to delete. It's just well, it creates a no terrain. This I'll go through in just a few minutes, a few seconds. But that's that. So when a terrain is made, this is the constructor that was called from the terrain object manager, the one that holds all the terrains. It's what you would expect: the graphics object, the cell row, side length, max height, and each made terrain has a double double array of cells. Yep, that's where it gets created, and it goes to the vert list of the model to get the proper cell values. And then here it actually just goes through every single cell, and then what's this part? Oh, and then sets the proper max and min altitude such that the boxes are aligned when in a terrain that's so yeah, but so that stuff there it is, so that these boxes are properly stuck on together neatly. There you go. That's what I was trying to say. So, yeah. What is special that does that need to be known is that current terrain it calls draw terrain, and that's where the actual render call happens. However, current terrain is actually just terrain object, which is the superclass for made terrain and no terrain. So terrain object, I'll hide that for now, has draw terrain as a pure virtual, and it also has a virtual void get terrain, and it also has a pure virtual get terrain segment iterator, and that's for the actual collision thing. I made my own iterator, and it passes a list, like a like a well, it passes an iterator that goes through the cell. That's it. This is what this is. I wouldn't say it's pretty, but it works. It was my first time trying to even. It's the first time being exposed to what an iterator is, how it's used, and how to make it. Kind of, because I don't even know if I made it properly, but it works, and it makes sense for this application. So, it has draw terrain and get terrain segment iterator. So the main terrain actually properly does what it's supposed to do. When you call draw terrain and it renders something, and when you call it get terrain segment iterator, it properly gets the proper. It creates the iterator and sends it back through references. But the null terrain, default null terrain, when it gets draw calls happens, nothing happens, and in the get terrain segment iterator, the begin is equal to the end. So, what do you call it? It never actually. It makes it so when this is called, none of the terrain cells are actually looked through in terms of processing. So yeah, that was the whole. Those two functions is the whole reason for there being a hierarchy over here. Yeah, in terms of just pure terrain, there's not much else over here, because I don't have like switching terrains mid-scene, mainly because that seemed dumb. It just seemed weird. But it wouldn't be hard to, what do you call it, implement, considering that all you really need to do is switch this pointer around and maybe have a container of terrains. I don't know. I'm just kind of spitballing over here in terms of that, but this very simple scene part. And going back to the actual collision terrain processing, I have another child of the collision processor base, so now we have pair, single, and terrain. In the terrain collision tests, it goes through the collidable lists and and then it goes through the collidable lists for the. So it goes through every collidable that wants to collide with the terrain. That's what's happening over here, and then it gets their loose AABBs, and then gets the iterator that I just mentioned. And so if there's no terrain, it's not even going to go through. It's not even going to go through this while call. It's just going to go straight past it. Else, it's going to go through it. So while cell it not equal to cell it end, and then cell it plus plus right here. That's typical iterator stuff. And so and this is the actual hierarchy. Collision functions AABB to AABB, and what that's going to do is go through the current collidable objects loose min and max, the big AABB in comparison to the cell IT's min and max, because the iterator holds, because each cell holds a min and max. Where is it? Where was I? Collision terrain processor. So yeah, and if that fails, it's going to show green, and then it's going to go ABB to the sphere, because each collidable has a sphere, right? So min and max, the ABB to sphere, and if that fails, you get cyan, and then this is where it gets a bit more complicated. I'm going to create a cell ABB. Well, a cell ABB is just a struct I made. I forget where. Where is it? Oh, I just created a pseudo axis aligned box at the start of the collision test. I think I mentioned this at Piazza. Couldn't figure out a different way to do it, and everyone else seems to do it this way, I think. And I just set its min and max over here, and then use that to test collision volumes. And then if that fails, you get blue, and if it succeeds and the actual terrain is collided, you get magenta. And that is how this happens. So as you can, over here, the green, because using the iterator got this this list for this ship and this list for this ship. They're all green because that's the big thing. That thing's turning to cyan because that's where the the bonding sphere is starting to touch. And the blue is, wait a minute, cyan happens if it's ABB to sphere. Yep. And then we have the dark blue, which happens if test against the actual cell fails, and then the actual part that hits is that little magenta spot. So if you look at it from on top, it makes more sense. All right, nice and pretty, and the bullets too. As you can see, let's see if I can freeze this. As you can see, there's a little cell going right underneath the bullet because it wants to collide, and then that's not what I want. Let's get the position. There it is. Oh, okay. This is really hard. There it is. There it is. So, the bullet colliding with the terrain. There you go. Pink, green, and it goes straight to pink because straight to yeah, and it goes straight because it's so small. I'm sorry, I lost my train of thought. And then that collides, so it actually disappears when it collides because I made it so it's a termination event upon the collided terrain call. So I think that's all of the terrain stuff. I showed you the asset manager, the scene terrain manager, collision processing, model creation, the operations I do, the visualizer. I don't know if I talked about this. I'll talk about the visualizer next, at the beginning of the next video. The math support classes I showed. I guess I'll just go through the tools real quick. Error out, it's the same thing from last quarter. It just allows me to print straight to the debug output. Math tools is what you saw. And in the constructor, I seed the random generator such that when I call get random float or whatever, it actually gets a pretty decently random looking value. Terrain tools is just the index stuff I just went over. Test globals is it's just a struct with a static variable such that I can have a global value that I can update and then use that to debug stuff. And I'll go over the visualizer in the next video, and I think that's it for the main system stuff that we went through. I'll go over the sheet real quick once during the compilation of this video and start the next one.